Hello. So in this video, we are covering the first of our sort of many types of actual factoring. So in this one, we're going to do what's called the coefficient method. So coefficient method. This is for one of those quadratic forms. Again, we're going to sort of put it in terms of the quadratics themselves, but it sort of applies to any of those forms where you can do some sort of appropriate substitution. So our general quadratic, right, this ax squared plus bx plus c bit, the coefficient method works when we assume that a is 1. So really we want just an x squared as our first term. The idea, right, is we want to write it in this form. We want to have some sort of factored forms. We want like x plus a number and x plus a number, multiply these two things together. That's our goal, right? And as often the case with math, it sort of helps to take the goal and work backwards. So that's what we're going to actually do. So brace yourself for a little bit of alphabet soup, but I'll pull out the pieces that we actually care about in a second here. So if we have this, right, our x squared, right, because again, a is 1, x squared plus bx plus c, we want to write it in terms of this sort of product of factors. If we expand out these factors, we can sort of link the forms, the starting form, to what happens after we expand it out. So that's what we're going to do. We're going to basically FOIL out this piece. So start by multiplying this x plus k against each factor, right? So x times x plus k and h times x plus k. And then we can separate, right, and factor out these pieces as well, right? Distribute out the x to the x and the k, the h to the x and the k. That gets us this mess. So then we want to group like terms. So we put the coefficients of x together, that k and h, factor out an x to get that k plus h, and we have that hk at the end. All right, bunch of letters, who really cares? So this is what we want to take away. We want to notice that this hk bit, right, this constant, has to be this constant that we started with, c. And those same h and k, if we add them together, has to be that sort of beginning part b, right, that coefficient of b. And what this tells us is that what we really want is two numbers, this h and k, such that they add up to that middle b term, right? So k plus h is b, and multiply h times k is that c. So this sort of motivates this coefficient thing. So once we've gotten sort of the general derivation out of the way, right, the general idea out of the way, it helps to have sort of concrete examples. So let's look at one of those. All right. So let's say we have this x squared minus 7x plus 10. So our goal, again, is to write it in that x plus h and x plus k part. Now, we want something, right? We want those two letters, h and k. We want two things that multiply to 10 and add to 7. So we're going to start by factoring out the factors of 10, looking at what pairs of numbers we can multiply to get 10. So obvious choice, 1 and 10. But 1 plus 10 is not 7, it's 11. 2 and 5, well, 2 plus 5, that's 7. That seems to work, right? Okay, so that should be our h and k. We plug those in, we get x plus 2, x plus 5. But not quite, right? So if we expanded this out, which I'm not going to put you through that, but if we expand this out, notice we're going to get a plus 2 times x and a plus 5 times x. So I'm going to get 2x and 5x together is going to give me a positive 7x. That's not what we want, right? What we want is negative 7x. So there is this sort of non-obvious step in the background, which is that we want to find two numbers that multiply to 10 and add to the 7, or more accurately, the negative 7. And when we look at factors that multiply to 10, we need to keep track of positive and negatives, and it makes a big deal, right? So we have 1 and 10 and 2 and 5. Those are factors, right? We do have 1 and 10. 1 times 10 really is 10. 2 and 5, 2 times 5 really is 10. But we also have negatives, right? So if I did, for example, negative 2 times negative 5, negatives cancel out. I still get positive 10. And in fact, now, if I use negative 2 and negative 5, those will actually add to negative 7, right? So we want to make sure that we keep track of the signs at the same time. And again, we can put these in, right, as our h and k. That's our proposal here. So I'm going to do the same thing with this sort of generic formula, but I'm going to put them in as they are. So I'm going to have x plus negative 2 and x plus negative 5, right? So it looks something like this. And then I can simplify that to be sort of more human-like, right? So we wouldn't have all these nested parentheses. So getting rid of those, it just ends up being this x minus 2 and x minus 5. Okay, so again, takeaway here, we want two things that multiply to the last number, add to the middle, and negatives are important. We got to keep track of those. Okay, so With that in mind, let's try another one. How about x squared plus 2x minus 15? So now the middle one is positive, which is always nice, but the last one is negative. So I need two things that multiply to negative 15, which means one of them always has to be negative, right? So for example, I could use 1 and negative 15. 1 times negative 15 is indeed negative 15, but adding them together, I get negative 14, not positive 2, right? I can also switch those negatives, and that makes a difference, right? So negative 1, 15, still negative 15, but now when I add them together, I get positive 14 instead of negative 14, right? So it makes a difference about the middle number. Unfortunately, it's not going to change the magnitude, meaning I'm still getting 14 of a type. I just get positive instead of negative. So it's definitely not going to work because, right, I need 2. So keep going, 3 and negative 5. Adding those together, I get negative 2. Right number, wrong sign, but that usually means I can switch the sign and look at negative 3 comma 5. Adding those together gets me positive 2. That's the one I want, right? And again, I plug this into my form for that h and k. Doesn't matter which one I make which. They're sort of interchangeable. So that gets me this x plus negative 3 and x plus 5, which again, when I clean it up, is x minus 3 times x plus 5, okay? All right, so what do? We introduced this idea of doing this factoring by coefficients idea. So this is the quadratic form, which we looked at just sort of basic quadratics, but the same idea for different forms. But it needs to have that leading coefficient, right, that a term being 1. And then we can just look at sort of the last term and the middle term, find two things that multiply to the last, add to the middle, and then use that sort of basic breaking apart, that x plus h and x plus k, keeping track of negatives as needed, and that gets us our factor form, okay? So that is that.